Hey guys, it's Milo, and this is Matlab video tutorial number 2 for Intro to Engineering, and the topic this time is arrays. So we're going to talk about one-dimensional arrays and two-dimensional arrays. Um, so first we'll talk about one-dimensional arrays, and of those there's two types. There's the column type, where all the elements are in the same column, and the row type, where all the elements are in the same row. I'll show you both the types right now. So I'm just going to type this out and I'll tell you what I did afterwards. So obviously this is a row array. There's 4 columns, but all the elements are in one row. And here is a column array. There's 4 rows, but all the elements are in the same column. So rows horizontal, columns vertical. So when you're manually creating your own arrays in Matlab, you're going to always put brackets around them, square brackets. And when you're entering the entries for your arrays, you're going to be separating them with either a space or a semicolon. And they have a different purpose each. So if you use a space, you're essentially pushing the next number that you type to the next column in the array. Just like I did up here. So 1 space, 1 space, 1 space, 1. This will give me an array where all the numbers are in the same row, because all I did was advance the next number to the next column. And you can actually do it with commas also. In this context, commas and space is exactly the same. That's not always true, but inside square brackets they are exactly the same. And just like before, we use the semicolon to advance to the next row, which keeps all the elements in the same column. So that's how you'd make a simple row or column vector. And you can put any numbers in there that you want. So let's get into indexing for these guys. So let me show you a couple more ways to create arrays, one-dimensional arrays. So there's one command called linspace, which is really useful. If you, it'll basically create a linear spacing between 2 endpoints, and you can tell it how many spaces you want it to have. So I'm going to use linspace. I'm going to have the endpoints be, I don't know, 3 and 7, and I want 10 intervals between them. So I hit enter, and it gives me a linear spacing. And this is an array with a linear spacing between 3 and 7. And what I mean by linear spacing is just the spacing between all the numbers is exactly the same. If you were to subtract any element from the previous element, you'd get the same answer. And there's 10 of them. So let's say I want to refer to the first 4 elements from this array. So it might help if I name it. I don't have to, but it might help. So I'm calling it A now. And if I do A 1 through 4, so a semicolon kind of means through. So I'm saying A elements 1 through 4. See, if I just do A1, I get 3. If I do A4, I get 4.333. And I can do A1 through 4 and get all the numbers between there. And that in itself is a 1 by 4 array, a row array, a row vector. Now let's if I'm going to make a new version of A. I'm going to call it B, and it's going to be the column version of A. And since it's a one-dimensional array still, I can use the same kind of indexing. I don't have to be specific about whether it's a row or a column at this point. I just want elements 1 through 4. And it gives them to me, and now they come back in column form. So that's cool. and I can now make a two-dimensional array. Now, a two-dimensional array, I'll make a square one first, but it doesn't have to be square. So here's a 3 by 3 array. It has 3 rows and 3 columns, and it's filled with ones. It's a square. It doesn't have to be a square. I could have made it a 4 by 3. So it doesn't have to be square, but it does have to be rectangular. If I alright, so let me show you how to make one of these. I guess I just showed you kinda, but in a similar fashion to how we were pushing the next element to a new row or new column using the spacebar or the semicolon, I can do 1 space 1 space 1, so that's like a row vector, and then use a semicolon, which will push everything else down a row. And now I'm going over by columns, and then down a row, and then over by columns again, down a row, and so on. So this should be a 4 by 3. And what would happen if the last row only had 2 elements in it instead of 3? See, I get an error message. It cannot concatenate the rows because the dimensions are not consistent. So the matrix, or the two-dimensional array, a matrix is kind of another word for that. It doesn't have to be square, but it does have to be rectangular. There are some commands for generating arrays quickly, special types of arrays. There's ones, and then you type in the size. You do the number of rows and then the number of columns. So we can do, let's say we want all number 1 in 4 rows and 1 column. And there you have it. And we can do 4 rows and 5 columns, 4 rows and 4 columns, etc. And there's a zeros command that kind of works the same way. And a rand command, which will give you random numbers between 0 and 1. Cool. Let me just check something real quick. Yeah. Alright, now let's say I wanted to pull some numbers out of this two-dimensional array. Let's say I wanted to grab these guys right here, 0.95 and 0.38, in a kind of systematic way, with indexing. That's what I mean by that. So I'm going to name this array C for convenience, not necessary right now. And I'll say C. Now let's see, what numbers do I actually want? The numbers I want, they're in the second row, and they're in columns 2 and 3. So I'm going to say second row, and then for columns I'm going to say 2 through 3, and hit enter, and it gives me back those numbers. So that is how you refer to specific entries in your arrays. Always row first, and then column, and you can use the colon to basically signify that you want you want all the elements in between the 2 endpoints that you specified. So in this case I want everything between 2 and 3. I could have made it everything between 1 and 4 if I wanted to. And you can even use the word end. So you can say 2 through end, and it will keep going until it gets to the end of that particular dimension. In this case, the end of all columns, which is 4. Cool? Alright, so we can do some basic math. I'm gonna clear all this stuff out, or at least clear the command window. We can do some basic math with these arrays, and it makes our lives a lot easier. If you ever have a list of numbers that a group of numbers that all need to undergo the same mathematical process, it's really convenient to put those numbers into an array and kind of treat it as one entity and perform your mathematical operation on that, and then you have a list of numbers as the answer instead of having to run through the same procedure a bunch of times. Let me show you what I mean by that. So I'm going to make some new variables. I'm going to use all random numbers in column vectors. So I can add A and B together in an element-wise way, and meaning that I can add, let's say I want to add the first element of A to the first element of B, and have that be the first element of the answer, and so on. So really what I want to do is C equals A plus B, and it's adding the first element of A plus the first element of B, and it's putting it in the first element of the answer. So the same thing works with subtraction. If you want to do multiplication in this fashion, you have to do it a little bit different. You have to use this. You have to use what's called the dot operator, which is just a period before your multiplication symbol, which basically is telling Matlab that you want to perform this operation in an element-wise fashion. So I'm going to print out A and B again so you can see what they were, so you can see that, I'm sure you believe me. So same thing with division. If I want to divide the first element of A by the first element of B and so on, I need the period before my division sign, like that. See, the thing is, if you don't have that period there, it actually does mean something different. So let's see what happens. See, that's not what I expected at all. That's not the answer that I want. I know that's what happens if I do multiplication. Yeah, it doesn't even work. You get an error message. So if you want to do basic arithmetic with your arrays, you're going to want to use the dot operator before multiplication, division, and raising things to powers. There is a page on the Matlab site that I will put in the description that gives a list of all of the array operators and the matrix operators, which we probably won't be using. Alright, I think that's it for this video. I probably went on for too long. It's fine. Thanks for watching. If you comment, I can answer your questions. Have a good one.